Добрый день, дорогие
Good
друзья.
afternoon, dear
Меня
friends.
зовут
My
Дромовский
name
Дмитрий,
is
я
Trumovsky
директор
Dmitry.
компании
I'm General
компании
Manager
СРТ.
of
Я вас рад всех
CRT Group of
поприветствовать
companies.
на
I
нашей технологической
am happy
сессии
to
Speech
welcome you at
Analytics.
our tech
Сегодня у
session,
нас с вами
Speech
очень
Analytics.
интересная и очень
We will
актуальная
have very
тема
interesting and very
по оценкам
relevant
аналитиков
topic for this session.
маркета,
According to
других
analysts'
агентств, размер мирового
assessments,
рынка
the
человеческой
amount of
уже
speech
достигает
analytics
$1,5 миллиарда и
market
прогнозирует
is reaching
его рост
1.5 billion,
практически
and
до
the
6 миллиардов
forecast
к 2026 году.
is that it will
Последние
grow up
уровни
to 6 billion by
20-22% в год.
2026, plus
Это очень
20%
приличный
growth
рынок, и,
annually.
конечно,
This is a very
такими же похожими
serious,
темпами
significant
растет и
market, and
рынок
the market
разговорного
of
искусственного интеллекта, conversational AI. И мы
conversational
сейчас видим
AI is
очень
also
активное
growing with the
сближение
same
этих двух
pace, and we
рынков.
see how these two
Понятно,
markets
нам нужны
get closer to
драйверы.
each
Это,
other.
конечно,
Yes,
потребности
we see
улучшения
the
клиентского
drivers, we need
опыта,
the
растущий
drivers,
спрос на
better
услуги
customer
поддержки
experience,
клиентов на
and
базе искусственного
more
интеллекта. И тут наши
more demand
клиенты,
for
которые пользуются услугами
support
разных
of
компаний,
services, and
ожидают одинаково высокого
we
уровня
expect
развития
quite high
сервиса в
level of
разных каналах.
development of various services
И
and
что это
various
означает
channels. What
для
does it
технологий?
mean
Для
for
технологий должны быть
technologists?
готовы к
Technologists
работе в
should be
разных каналах
ready
коммуникации,
to
в
work
разных
in
условиях, в том
various
числе
channels of
неконтролируемых.
communication, various
Нужны
conditions, sometimes
инструменты.
uncontrolled.
И о
We need
многом об этом мы
instruments.
поговорим
So we are
сегодня.
going to speak about all
Сегодня
these things
сессия
today.
Speech
Today's
Analytics объединяет
session,
все
speech
доклады как по теме
analytics,
голосовой
bring
биометрики,
together
так
voice
и по речевой аналитике, по голосовым
biometry and
роботам.
speech analytics and
Мы
voice
услышим, с
robots
какими вызовами
themes. We will hear
сталкиваются
about
компании-разработчики,
challenges
какие
face
задачи
and
решают
developing companies
сегодня.
face, what
И мне кажется, очень
what
интересно, у
tasks
нас
the
сегодня
developers
будут
tackle today. And it's great that we
более
will
научные
have
доклады от
more scientific nature
компаний-разработчиков, и будут доклады такого
reports from
более
developer
прикладного
companies
характера от
and those of
компаний
applied
и
nature from
участников,
companies
которые
and
используют эти решения в
participants who
повседневной своей
use such
деятельности.
solutions in their
Поэтому, мне кажется,
daily
сессия
work. That's
обещает быть
why I
очень
think this session
интересной.
will be very interesting.
И хотел бы еще
And I
напомнить
would like
нашим
to
уважаемым
remind
слушателям,
our
обращаю ваше внимание, что в течение
viewers,
сессии вы
please
сможете
note
задавать
that during the
вопросы,
session you can
которые
ask
вас интересуют
questions
для
you're
спикеров.
interested in,
Для этого нужно
questions to
просто вместе
speakers.
указывать
So
телефоном
you
на
just
QR-код, который вы
scan
сейчас
a
видите на
QR
экране, и
code
перейти на
on the screen
страницу.
with your camera and go
Мы
to
очень
a
ограничены
certain
временем, поэтому если у
dedicated page
спикеров
for your
время
questions. We
останется,
are
то,
pressed
конечно,
of
мы
time. If speakers have enough
ответим на
time,
наиболее
we will
интересные
answer the
вопросы.
most interesting
Итак,
questions.
давайте, коллеги,
So,
начнем.
colleagues, let's
И для
start.
первого выступления
And for the
я
first
с удовольствием
presentation, I
передаю
would like
слово
to give the
Алексею
floor to
Шолохову
Alexey
из
Sholokhov
Московского
from
исследовательского
the
центра
Moscow
Huawei,
Research
который выступит с
Center from
докладом «Голосовая
Huawei,
биометрия в
Speech Voice
ультрадрагонимых условиях».
Biometry
Алексей,
in
пожалуйста.
Uncontrolled Conditions is the title of the presentation. Alexey, please, you're welcome. Good afternoon, my name is Alexey Sholokhov. I'm engineer from Huawei. I work in voice biometry group. I'm going to speak about how to make voice recognition systems more reliable to work in complicated conditions. I will start with standard slide, just to remind you the main facts about voice recognition. This task can be split into two parts: verification, identification. Verification task is, for instance, we have a sample of voice of a person, and for a test, we need to say whether this is the person or not. For identification, we have not one sample, but many samples. And for a test record, we need to know whose voice it is. So the application of technologies of voice biometry includes deblocking your phone up to application in smart homes, anti-fraud, personalization of various services, and so on. On this slide, we show a general scheme of many modern systems for voice recognition. Conceptually, it is quite simple. As an input, we have a speech segment, and some low-level values are extracted. They go into the neural network. Then this network retrieves the vector imaging from the audio of a random length, and it is trained in a way that these embeddings, vector representations retrieved from the speech segment of the same person, are close to each other in the space of embedding. And embeddings retrieved from various people should be different one from the other. And after this, we can calculate a function of similarity between the embeddings and use the values to make decisions depending on the task we are tackling. In operations of systems for voice recognition, we can highlight two types of conditions they are working under. First, controlled conditions. It means factors that impact the quality of input record is limited. For instance, the background noise should not be higher than a certain level, or the length of the record we have as an input is not short. We need enough information to recognize the voice, and the users are interested in having a correct answer from the system. In uncontrolled conditions, we are going to speak about today, users might not be interested in correct answers from the system, and if so, they do not have an opportunity to give a system an audio record of proper quality. For instance, if he wants to record himself in a noisy environment, for instance, like in a shopping mall, and when we are working in controlled conditions, it's important to say that not all input audio segments are okay for recognition. And the system should know how to process such situations to avoid mistakes. And here, the picture to the right shows how assessment of similarity of two records depend on the level of the background noise. Blue curve is assessment of similarity of two records. One is a noisy copy of the other. And we see if the level of noise is very low, it means high values of S and R to the right. We have maximum similarity 1. And when noise is added to a record, the similarity value is going down quite expectedly. And the red line is the record of speech of various people, and when the level of noise is low, the similarity is low. That's how it should go. But when noise is growing in negative SNR, we see that, again, we have the assessment of similarity closer to maximum. And we don't want to have such behavior from the system. So, usually this problem is solved through the following. In the recognition system, we have a module that is in charge of assessment of quality of input data, and if it is not acceptable, then it might make a decision on declining further processing of such records. There are many options of how to implement this, starting with simple ideas like to assess the SNR for input record, or for instance, we can train a neural network for it to predict quality assessment. For instance, you can train it at the subjective assessment from people, structure such data set, or you can try and make it in a way that it predicts the same SNR. Artificially, this is easily generated, but the drawback of such approach is that for this we need to train an additional module that can use these assessments, quality assessment, to adjust the forecast of the system, adjust the decisions. Alternative option is to integrate quality assessment into the target function that is used for training the extractor of these embeddings and the representation that we retrieve from the record. And I will tell you more about one of such approaches. This is probabilistic embeddings. Deterministic embeddings are just dots in a space, and then probabilistic embeddings can be looked at as random values in this area. For modeling, we have several options. One of the most simple ones and convenient ones is normal distribution with dispersion parameter that can be interpreted as uncertainty of assessment in representation of this embedding. And we can expect that for audio records of low quality, this assessment, this sigma from the slide, will have large values. Actually, the whole idea of using the probabilistic embeddings in voice biometry is not new. For instance, at the beginning of 2010s, when I vector models were quite popular, I vector embeddings, the idea was instead of dot assessment to use the distribution, but for the whole model, the result, the dispersion was disproportionate to the record. Intuitively, we understand that the longer the record is, the potentially more information we can use for recognition. But unfortunately, there was no such direct correlation for other methods of for various audio records, for additive noise or something like that. For more modern systems that are based on neural networks, the same idea can be implemented through adding an input output to this neural network that also predicts uncertainty, where general accuracy is improving, accuracy of recognition.